Okay, get those notes out. So here's kind of what we left off with yesterday, right? We just had started. Everybody scoot forward if you can. Just scoot forward. Get as far as you can. Come on now. Get these good seats. You're going fast. You're going fast. All right. What's that? I am, yeah. Okay, so we had just started talking about circles, right? And I want to really reinforce kind of how we're doing this. So let me get everybody put all those, every distraction of any kind, just put those away. You got to really focus here. And this will be, here's the advantage of we'll get through this stuff today. I think it's really, I really enjoy talking about this. I think you'll like this. Tomorrow, workday completely. Friday, I'd be willing to maybe even give you workday Friday too. Okay. I think it's pretty likely we won't have school.
Really?
Yeah, I think so.
All
All right, so okay, so here's what we want to do then. We want to try to come up with the equation of a circle, right? But what's really important about this is we want to start with a pretty simple concept and sort of turn it into useful math, okay? So let's go back to this model that we had. Not that, not that, not that, not that. Oh, I want to keep that. It was this.
It's not raining. It's a good place to do that. It's kind of like burning. Just happened to.
Okay, so let's look at this situation. So we were talking about the definition of a circle, right? And we said the definition of a circle is really conceptually not a big deal. It's just going to be the locus of points, and we used a new word, locus, which means a set of points that fit certain conditions or criteria. It's the locus of points that are equidistant from some common point that we're going to call the center, right? So here's kind of a picture of how that works. So if this is the center and this is just some random point, that point can move around in what we now know as a circle, right? If I want to define that circle, it just looks like that then. Okay. So let's think about this now. If the center of the circle, we're going to call that C, what should the coordinates of the center be, do you suppose? Like, what do we usually think back to what we've done in the past? We've had, like we talked about, for example, absolute value functions. And whenever there was an important point on the function, we usually gave it certain coordinates. Like, what did we say that the, what's here?
Origin.
Yeah, well, what did we say that the coordinates of the vertex of a parabola were? Look, we gave them some letters. What were they? Remember? What was it? H and K. Yeah, that's it, right? HK. We'll do that all year. We're going to talk about parabolas soon. And we talk about the one important point on a parabola that's sort of unique. It's the vertex. And what do you think the coordinates of the vertex are going to be for the parabola? HK. That's right. They might be 0, 0, but we don't want to have to specify. We want to just say HK. So the center is going to have coordinates HK, right? Let me ask you this. Are H and K variables? And how come? I can see, yeah, defend your answer. How come? Okay, because H and K could be at different places, right? Like I could take this circle, for example, and I could move it around, and the center could be at different places, right? So it could have different values. The radius, in fact, let's put that in there. So we've got this other, here's the segment, and we're going to call that R, because that's the radius. Okay, that's how far away the point on the edge is from the center. So label, And let's call that R for radius. Okay. What about R? Is that a variable?
Yeah.
It is, isn't it? Right, it is. If I measure the distance from C to P, that's the radius, isn't it? Then that can change depending on what circle it is. Okay? So those are variables, right? Kind of. Not exactly. Because think of it this way. We can change the values of H and K and R, but every time we change them, we change the circle, right? Does that make sense? But once we decide on a circle, we've got to not change those anymore. Because once we've got an individual circle, then H and K and R are fixed. In fact, those are the numbers that define the circle. If I change H and K and R, I get a different circle, right? Let's say we want to have just this one circle that we want to use for a while. Then H and K and R have to stay the same, right? So really, H and K and R aren't variables in the way that we think of variables. They can be changed, but we think of them as being something different. We call them parameters. They're parameters because they're the values that define the circle, and because there's an infinite number of different circles, there are an infinite number of different combinations of H and K and R. But for a given circle, they're constant. They're fixed, right? Now let's compare that to this point up here, right? This point P. This is just meant to represent one point of the infinite locus of points that make up the circle, because we all agreed yesterday that there are an infinite number of points on the circle, right? And there's one, there's another, right? There's an infinite number of possible points. Think of, like we did yesterday, think of the circle as being like a wire hoop, and point P is just a bead that can slide around on the hoop, okay? What would we maybe want to call the coordinates of P? What do you think? Let me ask you this. Are the coordinates of P going to be variables? Okay, let's think about what made H and K and R something different than variables. We called them parameters, right? Because we said that they can change. Obviously, if we change the circle, the coordinates of P are going to change, right? Okay, but even if we fix the circle, right? So we make it, you know, we're gonna set the values of H and K and R and keep them constant. Even if we do that, are the values of the coordinates of P going to change? Are the coordinates of P the same there as they are there? Yes or no? What do you think? The coordinates are? The X and Y coordinates? They're different, aren't they? Right? They're different because that's a different point. That's a different point on the XY plane, right? Every time, even though the center is staying the same, and the distance between the center and P, which we call the radius, is staying the same, because the point is sliding around, its X and Y values are changing, aren't they? So would you agree that the coordinates of P really are variables? They're not parameters, they're variables, right? And what are the variables that we would usually use to assign a location in the XY plane? Well, I just said them. X and Y, right? So we really should let the coordinates of P be X and Y because they truly are variables, right? As we change for the bead from one location to another, we're going to be changing its X and Y coordinates, right? Make sense? Okay, so let's go to our picture then that we looked at yesterday. This guy, right? So here's our random circle. Here's the center of the circle, which has coordinates H and K, like we said, right? Those are parameters. And here's the point P that can slide around on the hoop, right? That's the point that represents all possible points on the circle. Notice that its coordinates are X and Y because they are variables, right? So we want to come up with here, the job in math, and this is really cool. The job in math here is for us to come up with an equation that we can use that's based on that simple concept, that all of the points are the same distance from the center. That's it. That's the only thing we need to use to define a circle. It's a set of points equidistant from the center. So all we've got to do is come up with a relationship between the locations of the center and point P in terms of the radius. And that's it. Okay? So what could we say about the length of segment CA? So that's just this segment down here. Think of it in terms of how far an ant would move if it traveled from here over to point A. And point A, remember, is just the point that's horizontally aligned with C and vertically aligned with P, like we talked about yesterday. And the reason we do that is so it can be a right triangle, right? So how far does the ant move? If he's traveling from point C to point A, he's traveling horizontally, so notice that the y coordinates are the same. He's not moving vertically at all. All his motion is going to be horizontal, right? He's starting at a value of h and ending at a value of x, right? Now, we talked about something yesterday. If we ever want to measure the change in a value, delta just means change, right? So the change in a value is always just equal to the final value minus the starting or initial value. For example, yesterday we took the example, if we start off with a value of 3 and end up with a value of 7, how much did it change? 4, because 7 minus 3 is 4. The final value was 7, the starting value was 3, so it changed by 4. Let's say you have $100 in your bank account at the start of the month, and at the end of the month you have $200. What's the change in your account balance? 100, because your final balance was 200, your starting balance was 100, 200 minus 100 is positive 100. Okay, what if you start the month with $200 in your account and finish the month with $100 in your account? What's the change? Negative 100, and the negative is actually important, right? That means it went down, okay, because it's 100 is the final value minus the initial value is 200, so which would give you a negative answer. So what are we going to get here? If we're starting with an x value of h and ending with an x value of x, what's the change? It's the final value minus the initial value, right? We're starting with h and ending with x, so x minus h. Good, right? What about the second part of the ant's journey? So we had him walk horizontally to there. Now we're going to have him walk vertically from points A to P. Yeah, so right, so in this case, right, the x coordinates, notice that the x coordinates are the same, only the y coordinates are changing. So we're starting at k and ending at y, so it would just be y minus k, right? Final value minus starting value. Everybody agree? Okay. And then the other one's pretty easy, right? CP, well, that one's given to us because we're defining the distance from C to P as the radius, right? That's just r. Okay, and that's got to be a parameter of the circle, so that's going to end up being constant, right? So we want to just relate those things, but yesterday we said if we have a right triangle, remember, if we have a right triangle with legs of length A and B and hypotenuse of C, what's the relationship between the lengths of those sides? A squared plus B squared equals C squared, right? Okay, and that's what I sometimes call a game show of this math equation, because I mean that's one of the very few ones that everybody's heard of, is the Pythagorean theorem. So if you go on a game show, and you might get asked that one, like what's the Pythagorean theorem? So that's A squared plus B squared equals C squared, right? So we don't have A, B, and C. We have CA and PA are the lengths of the legs instead of A and B, and the hypotenuse is CP, right? So ours would just become instead, it would just be CA squared plus PA squared equals CP squared, right? Well, we know what those are, right? CA is x minus AH, PA is y minus k, and CP is r. So then this relationship just becomes that, right? This is, turns out, that's the standard form equation for any circle, right? Now, why is that general? That works for all situations. How come? What are the numbers you would have to plug in to specify a circle? What would you have to do? To know a circle, you really have to know where its center is and what the radius is, right? And that would define the circle. So what values would I have to plug into this equation for a specific problem? Radius, I'd have to plug in a value for r. And what else? Yeah, h and k, exactly. Then I'd end up with, something like, who knows? I mean, let's try a problem. How about that one? What's the equation for this circle going to be?
7 minus.
Okay, good. So 7 is h, isn't it? Right? The coordinates of the center are hk, and r is the radius. So h is going to go there, so that's 7. Agreed? K goes there, so that's 4, right? And r goes there. So we just end up with x minus 7 squared plus y minus 4 quantity squared equals 6 squared. What's 6 squared? 36. So that's it. That is the equation for the circle described right there. Okay? Why does it have an x and a y in it? We need variables, don't we? Because the variables are there to represent all the possible values of x and y for the coordinates of every point on the circle. But only the ones that actually fit on the circle are going to work in this equation, right? Okay? Let's try another one. So let's make this one step harder. So what about something like this instead? Same kind of a problem, only this time they didn't give us the radius. They gave us the coordinates of a center and the coordinates of another point that's on the circle. Yes, Kim?
Would it be x minus 16 squared plus?
Good.
4.
Okay, good. So we're recognizing that this is the center, so that's h. It's giving us the values of 2 of the 3 parameters that define the circle. That's pretty good, right? So just using that information right there, we're able to turn this into x minus 16 squared plus y minus 5 squared equals r squared, right? But I need one more thing. I need to know r. I've got to be able to fill in, because all this tells me is where the center of my circle is, but I don't know how big it is, right? I've got to be able to specify what the radius is to pin that circle down, right? So any ideas? What could I do?
Put 8 and 4 for the x more.
Okay, yeah, I could. I could plug in, I could use the values of 8 and 4 because I know they're going to work. I was told here that the circle contains this point. So those are values of x and y that have to satisfy my equation. They have to make it work. You've done stuff like this before. Let me remind you where you did stuff like this before. You did stuff like this before if I gave you, let's say we're going to use the slope-intercept form of a line. Do something really simple like a line. So y equals mx plus b. What do you suppose we call the values of m and b? Are they constants? No, what are they? Not variables. They're the slope and y-intercept, and what's title do we give, or what name do we give to things like that? Parameters. They're parameters because they're going to change from line to line. There are an infinite number of lines out there, and each one of those lines is going to have its own unique combination of m and b, right? But for a given line, then instead of having a wire hoop, we just have a wire strand, right? We would have a wire strand going forever, and there's a bead that we can slide along that wire strand. The coordinates of the bead, the point that's on the line, would be x and y, right? So they're variable, okay? But we need to be able to know what's the slope and what's the y-intercept to define the line, right? So what if we had something like this? Let's say this is the information we're given. Let's say we know that we have a line with a slope of 2 through the point, how about 1, 6? I want to specify the line. Well, they're giving me one parameter immediately. What is that one? 2, right? They're telling me that the slope of the line is 2, so that's telling me m equals 2, right? So then we can write the equation of our line. We know it's going to look something like this. It's going to look like 2x plus b. But they didn't give me b. How could I find b? Yeah, I know a solution. I know that the line goes through the point 1, 6, right? So I should be able to plug in, that's just a value of x and y that work. So I should be able to plug in 1 for x and 6 for y. And if I do that, I get 6 equals 2 times 1. That's supposed to be a 1. That's terrible. Oh. 2 times 1 plus b. So what's b? No. 4. How'd you get that? Tyler, how'd you get that?
2 times 1, and got 2, and then subtract 2.
Okay, we subtract that 2 away to the other side, and we get 4 equals b. Aha, so now what's the equation of my line?
2x plus 4.
Yeah, good. It's going to be 2x plus 4, right? So I got to write it with my variables in there, but I've got to be able to plug in the values of both parameters to specify the line, okay? So you remember doing that, right? You've done problems like that before in Algebra 1, agreed? Okay? This is just kind of an Algebra 2 equivalent. So now we've got, instead of a line, we've got a circle, but we have these values of x and y. So I could plug 8 in for x and 4 in for y in order to be able to find out what r squared is. Do I really need to know, if I want to write this equation in standard form, the circle, do I need to know what r is? Not really, do I? I just need to know what r squared is, because that's what I have to plug in as a number for r squared, right? So this ends up being even a little bit easier. So if we do this, we end up with 8 minus 16 squared plus 4 minus 5 squared equals r squared. So let's just simplify this. What's 8 minus 16? Negative 8. Squared?
64.
64. So this all becomes 64. What's 4 minus 5? Squared? 1. 64 plus 1 is what?
65.
So 65 equals r squared. So now that's what I can plug in there, right? So what's the equation of my circle going to be? Maisie, what's the equation going to be that I would write down for the circle in general?
Would it be like 65 pi?
No. All I want to do is plug in the, remember, my goal here, let's go back and look at this. My goal is I just want to be able to plug in the values of all the parameters, right?
Would it be 65 squares?
No. So I don't want, I have to have x's and y's in my answer, right? I used a value of x and y to find r squared, but now I gotta get rid of that. I just want to start with my original standard form equation and only plug in the values of the parameters to specify the circle, right? So I'm going to start off with x, what? Minus 16, good. X minus 16 squared plus y minus what? 5.
Equals
Okay.
65.
Oops.
I was like,
5 equals 65. Good. Because r squared equals 65. Right? Does that make sense? No, we don't. We don't. Because what shows up in the standard form is r squared. So now, what if we asked you a different question? What if I said, okay, what's the radius of this circle? What would it be? If r squared is 65, what's the radius of the circle?
65
The square root of
Yeah.
65. Yeah, right? Does that make sense? Okay? But that's it. Okay, you try one. Try that.
So so do you just put in the middle 65?
So you'd put in just 65 in the equation. Yeah, whatever r squared is. So try that. I'm going to come around and watch you do this. See how you're doing.
Pause it.
Oh, thank you. Unpause. Okay, so here we go. So we've got,
Oh, it was unpaused.
okay, so I've got H and K, don't I? Right here, they gave me the coordinates of the center, so that's H and K, so I can plug those in. So I've got most of it done. I get x minus 3 squared plus y minus 14 squared equals r squared. The only thing I have left to do is find r squared. I need to know what that is and plug it in and I'd be done, right? The way I can do that is by using this value of x and y, right? So I would write this then as -8 is my x value, so -8 minus 3 squared plus 12 minus 14 squared is going to equal r squared. Well, this is just -11, right? -11 squared plus 12 minus 14 is -2 squared. And what is that stuff? Well, that's 121 plus 4 equals 125. So all I've got to do is plug in 125 right there, and I'm done, right? My answer would just look like x minus h, which is 3, so x minus 3 squared plus y minus k, which is 14, squared equals r squared, which is 125. Done. Okay? All right, last one. Let's look at this. Okay. Now, here's the goal with this. This looks horrible, but it's not that big a deal. We've done stuff like this in Module 3. Don't panic. So we want to write this in. I need your absolute attention on this. You got to really focus. We'll finish up with one of these like on Friday. So if we're here. So we want to get this into standard form, right? So notice what that looks like. It looks like a perfect square factor for x and a perfect square for y equals some number, right? So for us to get there, I just want to put that away for now so it doesn't look confusing. It means all I've got to do is just create perfect square trinomials and turn them into perfect squares, right? Perfect square factors. But before we do anything on these, we always want to ask ourselves, can we make this easier? Is there something that is there a greatest common factor that I could divide out of everything?
Or just 2.
2. All those are even numbers, right? So I should be able to divide everything by 2 to make it simpler, okay? So then that's going to give us, if I divide both sides of the equation by 2, what's the first term going to be?
X squared.
Second term.
Y squared.
Next term. Okay. Okay, good, good. So now let's look at it here. So we want to create a perfect square trinomial for the x's. So let's do it this way. Take good notes on this. So we're going to take all the x terms and let's put those together so we can fill in a blank and create a perfect square trinomial. So we're going to write that as x squared plus 8x and leave a blank, right? What about the y's? Same thing. Let's collect all the y terms and leave a blank. And then on the other side, let's put the constants. So we'll subtract 16 from both sides and get -16. That ought to look pretty familiar, right? Because when we do this, we're going to take the red stuff here, the x's, and we want to turn that into a perfect square trinomial that factors, right? We're going to take the blue stuff and turn that into a perfect square trinomial that factors, and then end up with some number on the other side. So let's look at the red stuff. I want to create a perfect square trinomial, but I already know what the perfect square is going to look like. What's the number that goes there? Positive 4. Good, right? So, well, B is 8, right? And it's half of B, right? Okay, so if I know that's a 4, then what's the red number that I've got to add to both sides? Good. It's going to be 16. 4 squared. Good. So I'm going to add 4 squared, which is the same thing as 16, right? And then that's good because that created this perfect square factor, right? What about the blues? if that's a -6, if B is -6 for the blue stuff, then what's the number that I combine with Y? -3, which means, what's the blue number that gets added to both sides? 9, very good, okay? So, the left side, we've got it the way we want it. The right side, we have to just add those up. Well, -16 and 16 cancel, so what am I left with? 9. Done. How about that?
Whoa.
Seriously, do you guys, now, honestly, just take a second.
Where do you get the
And
9?
the 9, because
Can't-
-16 plus 16 is 0 plus 9.
Where do you get the 9?
Okay, I get the 9, listen, oh, hang on, listen. I get the 9 because I started off with a -16, right? And I had to add 16 to both sides and 9 to both sides to create the perfect square trinomials. It is, so that's 4 squared. Let me write it as a 16. Would that be better? Okay. So I added 16 to both sides and 9 to both sides, right? Okay, now honestly, take a second here and just reflect on what you just did. Think about this. That's pretty good. If we went back a couple months and I put that on the board, you would have just panicked completely, right? I mean, you're getting better. That's pretty good stuff, right?
So how would you put that in Google?
Just exactly like that.